can remember how to record. Although I am recording the outside one, so I guess that doesn't really matter. All right. So thanks for joining me in Big Blue Button today. It's been a while since I've used this. In fact, I don't know where my tools went for the whiteboard. There they are. So if I'm a little bit sloppy on the board, I apologize. Things are kind of like almost backwards from Blackboard Collaborate setup. So hopefully it'll be okay here. There were a lot of technical issues early this morning, so the teachers couldn't get in, even though the students could, into Blackboard Collaborate. So we decided to use Big Blue Button here this morning. And then right before class started, go figure, Blackboard Collaborate fixed our links so the teachers can get in now. So we'll just stay in here though, since everybody's here already. It doesn't really bother to switch back over to that. So everything is very similar. The chat though should maybe be on the left-hand side or on the right-hand side, sorry, unless you moved it around, because I think you can play with the layout in here. So everything else should be pretty much the same there. All right. Were there any questions with the 4.05 stuff? So your graphs of your other trig functions besides sine and cosine? No, everything went pretty good. Okay. You will need a calculator for this lesson. You're going to have to use your inverse button. Now, I do want to mention that I think on 4.05 it was the last question. You had something like the secant of x equaled some value. And you had to solve for x in there. Well, you had to use an inverse function in order to get your x. And some of you actually remembered that from your geometry days, which was awesome. So to get rid of the cosine function, because you had to first of all rewrite secant as cosine, to get rid of the cosine and just be left with the x, you knew you had to take the inverse of that. So we actually were using the inverses a little bit prematurely in the 4.05 with that last question, but you should have hopefully remembered some of that from your geometry days when we did talk about your sine, cosine, and tangent functions and the inverse of those to kind of get your degree values or that x by itself. We're going to extend on that idea today when we're looking at our inverse trig functions. All right, so the first thing we're going to look at obviously is the sine function. So just the 3, because with the reciprocal function, so cotangent, secant, and cosecant, you have to revert or convert that to one of your main 3 trig functions, sine, cosine, or tangent. Because when you look at the calculator, you'll notice that you've only got those 3 options available to you. So even though we may be working with secant, cotangent, and cosecant, you still got to relate it back to these 3 buttons here somehow. So we are just focusing on these 3 main things today. Now, your sine, cosine, and tangent functions, they're not one-to-one. Does anybody remember what it means if a function is one-to-one? There you go. Awesome. It does. It passes both the horizontal and the vertical line test. So the vertical line test is what we use to decide if a relation is a function, first of all, right? So it's got to pass the vertical line test. And then we use the horizontal line test to see if it's going to be one-to-one, which basically means that the inverse of that function is also going to be a function. With our sine and cosine and tangent functions, because they repeat, right? Sine and cosine are waves, first of all. And then tangent repeats itself many times, like vertical waves almost, like looking at the beach, I think is Isaiah is how put it there. They're going to fail the horizontal line test. So in order to find inverses of these three trig functions, we've got to restrict the domain. If we restrict the domain to just certain pieces of the graph, then we can call it one-to-one. So we really want to make sure that we just restrict the domain for where we're going to be looking at for the inverses of these functions, which really isn't that big of a deal. All right, so for sine, when they say restrict the domain for the sine function and tangent function, because if you think about it, tangent is technically that's sine over cosine, isn't it? But for sine and tangent, they're looking at the restricted values of the quadrant 1 and quadrant 4. So from pi over 2 to negative pi over 2. If we look at it in just this part, then it will pass your horizontal line test and be a one-to-one function. So we're only going to be searching for answers in this area for sine and tangent. Before we talk about cosine real fast here, let me just point out the notation that they use. They don't just use the invert, like the -1, which is what we're kind of used to seeing. So sine to the -1 power of x, we're used to seeing that represent your inverse function. But they also, now that we're in that advanced math area, they use arcsine or arccosine or arctangent as well. So if you ever see something written out like this, arcsine of x, that means it wants you to find the inverse of sine of x. So the arc piece is referring to the inverse piece. All right, any questions with the notation aspect of that at all? We're pretty used to that -1 exponent for inverses, but the arcsine I think is something new to us. Okay, before I talk about cosine, we do have some problems here for us to try out with just the sine function to get used to it. Now, some of these it's going to say you can do without a calculator. Some of them you have to use a calculator for. All right, so most of them can be done without. If it says to do it without a calculator though, you must, and I repeat, you must use your unit circle. So another reason why I told you that unit circle is your best friend, because when you have to calculate something without the calculator, you need to rely on that to get your answer. If the value that they're asking you to find inside parentheses does not appear on your unit circle, that's probably a good indicator that you can use your calculator then instead. All right, so how this is going to work is we need to evaluate the sine inverse of 1/2. So remember, sine inverse is between quadrants 1 and quadrant 4. So we're looking somewhere in here for our answer. And we're looking for where sine equals 1/2. So remember, in your ordered pairs, it's cosine sine. So where exactly in quadrant 1 and 4 does sine equal 1/2? I see pi over 6. Remember, we want, and this is, I wish I had a highlighting tool in here. I don't think I do. That's one disadvantage. It goes, cosine is first. I thought so too. I can't seem to find it either. And sine comes second. And I don't know why I feel so weird writing on the board in here compared to Blackboard Collaborate. I think it's just a comfort issue. Yeah, so we're looking for that second value of 1/2, and that would be right here. at pi over 6 or 30 degrees. That is your answer then. So it's really just that simple. Using the unit circle, and we're almost kind of using it like backwards, right? So pi over 6 or 60 degrees, depending on if they want it in radians or if they want it in degrees. I would say 9 times out of 10, they're working in radians. So they're probably looking for this pi over 6 answer versus the degree representation of that. Okay, let's see if I can switch to typing because I'm really not comfortable with the marker there. All right, how about the next one? Once we start doing these, oh, sorry. Yeah, you're right. That is 30 degrees. That was totally my bad. I used a combination of your and Tommy's answers, but it's really the pi over 6. Okay, darn brain. It is. Yep, that's 30 degrees. All right, how about the next one? Sine inverse of negative square root 3 over 2. Be careful, because technically there's two answers where sine is negative square root 3 over 2. We should only be looking in the restricted domain for that. Where is sine negative square root 3 over 2? 300 degrees. 5 pi over 3. Beautiful. Yep, right down here. So I'm just going to see if I can type a little better. What was the alt code for degrees? Does anybody remember? Tommy, do you have that memorized by chance? Or Isaias? You guys are good with your alt codes. There we go. Thank you. I knew you guys would know that for me. See, I really need to keep sticky notes available. I mean, I have the physical post-it notes everywhere around my office, but I never use the ones on my laptop. I probably should. All right, how about the next one? Sine inverse of pi over 2. It's written a little bit differently. Where is pi over 2, by the way? At 90 degrees. Pi over 2 is up here at 90 degrees, right? Let's go back. That's right where the domain begins. So we have to go back and see, is 90 degrees or pi over 2 actually included in the restricted domain, or is it strictly greater than or less than? So does it have to appear actually in quadrant 1 or 4? So let's go back, because I didn't pay attention to that close a detail. It looks like it possibly could be, right? It's got the bracket there. So if it is, then I would say that that value would equal a 1. So if it's included, it's going to equal a 1. Let's see if that actually pops up okay on our calculator or not. Ooh, it doesn't. Okay. So this is what happens when I plug that into the calculator. So I want you guys to go ahead and try the same thing. So make sure you're in radian mode because we are working with pi. So if you're not, you might be in degrees still from the last lesson or whatnot. So go over and change that into radian mode. They do. Yeah, so a bracket includes it. That's like the equal sign, like so greater than or equal to. It means that number is included. A parentheses means it's not. So it would be like you're greater than or less than. but not equal to it. Yep. And this is where I was going to check that restricted domain because it's right at that beginning spot up there at 90 degrees. Now when I put that into my calculator and I hit enter, it gives me a domain error. So that's where I was questioning if it was actually included or not. So according to my calculator, it's not included because we get that invalid input there. That's weird, Tommy. You get an actual point instead of one answer? That's weird. So, yeah, the format is weird. I've never seen that where an ordered pair is given as an output. That's kind of strange. We may have to check on that. Yeah, are you doing pi over 2 or sine inverse of 1? Pi over 2. It looks like it's almost translating pi over 2 to, like, because pi over 2 looks like it could be 1.57 almost. And then I'm not quite sure where the negative 1.02 would be coming into play. That's weird. I'll have to think about that and see what's going on. Anyways, if the calculator gives us that error, let's go with does not exist right now. So DNE. Because it's right on that boundary line. And if it is included, then it would be a 1. If it's not included, then there's no answer. So, oh, I think I get why it doesn't exist there. Pi over 2 is 1.57, like Tommy had said. Yeah, I'm not sure. I don't get the extra stuff either. And the domain can only be between -1 and +1, right? I think we saw that, -1 and +1. But pi over 2 is greater than that. It's 1.57. So that's out of the area of the domain. So I think that's why the calculator is not able to do it, because of that reason there. Okay, now what do we know? Think back to our geometry days, right? Sometimes we gotta be smarter than the calculator maybe, although that's hard to do at times. Hopefully as we move forward, especially when we get to example 2, we can maybe get your calculator figured out, because you're really gonna need that when we get to example 2. If we can't figure it out on your calculator, don't worry. We can use the one that's on the computer to get you there. So the ones on our laptop actually can go ahead and perform these inverse functions for us as well. So even if you don't have an advanced graphing calculator, you can still get those answers. All right, looking at parts D and E, what do you remember from your geometry days about sines and their inverses? Or I should say functions and their inverses. And maybe not necessarily just geometry, but all together. Yeah, they cancel each other out, right? So when I see sine inverse and sine, as long as that value that's listed after that is in the restricted domain, it should cancel each other out. So if pi over 9 is in the restricted domain, and let's just go ahead and check real quick if it is. So pi over 9 is a 0.34. 0.34 is between -1 and +1, so it should be okay for our domain. So if it's okay for the domain, those are going to cancel out, and we are left with just the pi over 9. All right, now 5 pi over 6 is a little bit different. That's 2.61799. That falls outside of our domain because 5 pi over 6 is right here in the unit circle. However, I can relate that to a spot that's in the restricted domain. Where is phi? So if I'm looking at sine of 5 pi over 6, that's the same thing as 1/2, right? So instead, can I go sine of 5 pi over 6, which is out of the restricted domain, but if I simplify that to just a 1/2, right, because that's what it is at that location, a 1/2, can I take sine inverse of 1/2? I can. That looks a lot like part A, right? What is sine inverse of 1/2? And if we just bounce it back, we can see it right there. It should be 30 degrees or pi over 6, right? So sine inverse of 1/2 is the exact same thing we had in part A, and that was your 30 degrees or pi over 6. Is pi over 6 the same thing as 0.52? It is. Okay, good. Questions with how we got part E there? So doing sine of 5 pi over 6 first before we applied the inverse of that. All right, can you guys actually type on the whiteboard? Do you guys have those tools available to you? Okay. I don't know how to give that to everybody. I don't know if I can. Does Miss Cisneros ever like allow you guys? Okay, how do I do that then? Oh, what about this? Now can you? Yay! Awesome! Alright, see all your names popping up. That's awesome. Okay, see, I told you, it's been a while. Some of the features have updated since I've been in here last. Alright, so let's go ahead, try part 2. You will need a calculator to do this. It says make sure you're in radian mode. So again, if you haven't already switched over, go make sure you're in radian mode. This is where we're going to test Tommy's calculator and see if she gets an acceptable response. All right, so the last one, 5 pi over 6, if I go up to part E real fast, 5 pi over 6 was outside of our restricted domain. So notice how it's over here in quadrant 2 instead of 1 or 4. So what we do is we try to simplify that if possible. So sine of 5 pi over 6 was the same as 1/2, right? That's what that actually equaled. So I replaced sine of 5 pi over 6 with that 1/2 value. And then I was just left with sine inverse of 1/2 to calculate. And we did that the same as we did in part A. Sine of 1/2 was pi over 6. All right, use your calculator for part A and B. When you have a value, go ahead and put it on the whiteboard. Let's make sure we can get our calculators working properly. All right, we got some values up there. Tommy, did your calculator end up working here? Okay. I got the same thing that you guys put on the board. And I wasn't looking because I was staring down at my calculator at the time, so I missed who put it up there. But those are the exact same values that I got as well. All right, if you can't, if your calculator is not working, you can go ahead and use the calculator that's on the laptop. Just make sure that the little radians button is checked, and then you're going to want to check the little inverse button as well. They should if the value inside the parentheses is within the restricted domain. So for that one, you have to tweak it a bit because it's not within the restricted domain, right? It's got to fall between -1 and +1 for the signs to cancel out. So essentially what it's doing is kind of what we did up in part E. It's simplifying what sine 3.49 pi is, and it's putting it back into quadrant 1 or 2, and then it's doing finding the sine inverse of that value. So it's doing a little bit extra work for us there by bouncing it back into quadrant 1 or 2. So that's why you're not getting the 3.49 pi as your answer, because that 3.49 pi is not within the restricted domain. And that's actually going to lead us up nicely into an upcoming slide. So I'm glad that you found that or saw that problem there. Cosine, their restricted values for cosine for the domain falls between 0 and 1. So 0 and pi. So it's a little bit different than sine and tangent. Again, notice the notation that they're using, arc cosine, right here, arc cosine, or they'll actually spell out cosine, or cosine to the -1 power. Tangent is the same as sine, so we're not going to think too hard about our tangent function. Okay, I'm going to come back to that last slide in a moment here, but this is what I was talking about because Tommy asked, why didn't the signs cancel out? It says, we've already seen the need for caution when applying the inverse composition rule to the trig functions and their inverses. The following equations are always true whenever they're defined. So if you're starting with the inverse inside, your tangent and your inverses will always cancel out. Right? So if the inverse is inside the parentheses, then you don't really have to worry. However, if the inverse is on the outside of the parentheses, then you have to proceed with caution. These will only cancel out if the x values are in the restricted domain for sine, cosine, and tangent, which we saw that happening in the example 2, where the signs did not just cancel each other out because we were outside the restricted domain. So Tommy brought up a really good question there, so I just wanted to jump ahead and show you those rules for when they will cancel and when we have to be a little bit more cautious. Okay, let's go back a slide and see if we can find these. So cosine inverse of -√2/2. Remember that is, cosine is, we're looking at quadrants 1 and 2. So where exactly is cosine inverse going to be -√2/2? Remember, cosine are the x values. Three pi over 4. Yep. I like that. Okay, well, I am working on writing this on the board as neatly as possible. Let's go ahead and do tangent. Tangent, again, is quadrant 1 and 4. So same as sine. You're over on this side of the unit circle. Remember, tangent is sine over cosine, so you have to do a little bit of simplifying there, but you can at least narrow it down to what quadrant you should be looking in. If it's a positive value here, are we looking at quadrant 1 or are we looking in quadrant 4? So it's just a positive square root 3. Which quadrant do we look for Well, quadrant 4 would be a negative over a positive, so that gives us a negative outcome. Yeah, we're restricted to just quadrant 1 then. Yep, because it's a positive divided by a positive. That's going to give us our positive result. So we at least narrow it down to just these 3 choices. And we actually can eliminate the middle choice because that's just going to be a 1, right? 45 degrees for tangent is 1. So that's not what we're looking for either. So really our chances are narrowed down to 60 or 30. So which one is it going to be? Where is tangent going to equal square root of 3? If you had to guess again, what would you guess? It is 60. Yeah, remember tangent is sine over cosine. So the sine values would come second. Yeah, so I'm guessing you guys did it backwards. So if I look at 60 degrees or pi over 3, that would be the square root of 3 over 2 over a 1/2. Notice the 2's are going to cancel, and you're left with the square root of 3 over 1. So just make sure you're not setting it up backwards. With your ordered pairs, it's always cosine and then sine. Seems really weird, right? But cosine comes first in the ordered pair and sine comes second. All right, the last one, we need to proceed with caution, right? Because cosine is on, or the inverse of cosine is on the outside. It's not in the inside here. Is negative 1.1 within the restricted domain? Blah, if I could spit that out. Is negative 1.1 in the restricted domain for cosine? No, everything's between negative 1 and positive 1, or 0 and 1, I think there. Negative 1 and positive 1, it's outside the domain no matter what. So to do that, you've got to kind of bounce it back into the restricted domain. Because this is not on the unit circle, I would recommend probably just using your calculator to do this one. Let's go ahead, type it in. What do you get when you plug that into your calculator? So because negative 1.1 is not a nice value on the unit circle anywhere, use your calculator instead. And what do we get as a result? A 1.1. That's what I got as well. Yep. So that's going to be our answer then, is a 1.1. So I know it said to do it without the calculator, but because that's not anywhere on the unit circle that we can actually perform nicely and figure out what to do there without using a reference triangle, so to speak, I will allow you to use your calculators for that. What they're doing is they're doing cosine of negative 1.1 first. They're doing that simplification process. So they're doing that first, which is going to put it back into the restricted domain, and then they're going to find the inverse of that value. Yeah, so they're actually going to be simplifying it first. They're going to do the inside piece first. And doing that inside piece to simplify it, the cosine of negative 1.1, that's going to bring it back into the restricted domain for us to actually calculate. Let's go back and look. I want to say it's between quadrants 0 and, or between 1 and 2. But let's go back to that. And yeah, so 0 to pi is the range, but it looks like negative 1 to 1 is the restricted domain for all of them. Except for tangent. Tangent's a little bit different. Tangent, there is no restriction really. But you should be looking in quadrants 1 and 4. But for sine and cosine, if I go back, domain is -1 to 1. So it's just barely outside of the domain, but that's what it is there. Yeah, so if I just refresh your memory slightly here with what we did with the cosine, notice how in part E here with the sine, that was outside of the restricted domain as well, but we simplified that. So this was outside of our domain as well, but then we were able to simplify that to bring it back in. That's what they're doing with that cosine of -1.1 as well. They're simplifying it first so that we can take the inverse of it. Okay. Now again, the rules are if the inverse is on the inside of the parentheses, then it's going to cancel no matter what. If the inverse is on the outside of the parentheses, then you proceed with caution. So some of these we can go ahead and calculate fairly quickly. Well, maybe not, because these all look like they're different inverses of each other. So I take that back. If these would have been the same functions, some of them would have canceled nicely, pretty quickly. But doesn't look like that. This is going to be a two-step process then as we go and solve these. So you have to do like your order of operations. You have to work inside parentheses first. So for this first example, let's start by finding the sine inverse of 1/2. What's the sine inverse of 1/2 using that unit circle? That was our pi over 6, right? All right, so then we're looking at pi over 6, and the inside here, that's what that simplified to. Then we have to calculate what is cosine of pi over 6. Yep, you're still using the same ordered pair. You're just looking at the cosine value of that, square root 3 over 2. Good. So square root 3 over 2 is actually going to be the final answer then. So two-step process with these. So let's start with the next one. You have to start with cosine of pi over 4. What is cosine of pi over 4? Square root 2 over 2. All right, now we're left at finding the sine inverse of square root 2 over 2. Don't look too far because you're not going to have to move too far. It's going to be the radian version of that. So you're looking for where sine equals square root 2 over 2. It's at that same ordered pair. That same ordered pair is occurring at pi over 4. Yep, so the pi over 4 is the answer that we're looking for in part 2, or question 2 there. Good. How about the next one? Let's start on the inside here, and then we'll apply the 2 in a moment. What was sine inverse of 1/2? That seems to be a very common example they like to use. Yeah, we've done that one many a times today already. Pi over 6. So we're going to do cosine of 2 times pi over 6. Well, what does 2 times pi over 6 reduce to? Pi over 3. Good. So now we're left with trying to calculate what does cosine of pi over 3 equals. 1/2. Yep, it's all about being able to use this unit circle. So you're going to find where is cosine equal to 1/2? Right here at pi over, or sorry, where is cosine pi over 3? My bad. Here's pi over 3. The cosine value of that is 1/2. So it's all about being able to read this unit circle kind of forwards and backwards. How about the next one? What is cosine of pi over 3? We just did that, right? The 1/2. So now we're left with taking the sine inverse of 1/2. So we're trying to find 1/2 where sine equals 1/2 on the unit circle in the restricted domain area. Where does sine equal 1/2? At pi over 6. That wonderful pi over 6 again. All right, last one. Where does tangent inverse of square root 3 equal? Or what is the tangent inverse of square root 3 equal? Pi over 3? Yay, you remembered. So then we're left with calculating cosine of pi over 3. One half. All right, are you guys feeling a little bit better with how to use the unit circle to work with your inverses here? Too funny. All right, real quick, let's just make sure your calculators are still working before I send you off today. Find tangent inverse and sine inverse and put it on the board. Good one, Tommy. If you type, can you move it around? Like, can we grab it like you can in Blackboard? Interesting. Right? I was trying to move mine too. I wasn't quite sure. Anyways, I get the same answer for the tangent. 1.172 technically. 1.171519591. Sine we'll just put underneath it, I guess. There you go. You had me worried for a moment. You guys get the same thing? I like seeing how the names move around on the board. All right, good. Let's see. Do the next one right here then. Let's see what we get for these. Oopsie. right, did I get the same thing? 0.3704, negative 1.491. Looks good. All right, the last one, let's have you guys divide and conquer since we're running out of time here. These are the inverses, so make sure you're looking in the correct restricted domain. So for sine and tangent, you're looking at quadrants 1, 4. For cosines, the oddball out, you're looking at quadrants 1, 2. So pick one or two of them to see if you can answer and throw it up on the board. Good. Cosine is 0. The last one is pi over 2. That one's good. I'll put a little smiley face there. I know we can't move them, but it's good. That's all right. Yep, cosine inverse of 1/2 is pi over 3. So nice job, Rebecca. I think that was you that took that one. Nice job. 4 left. See if I can change my color. Look at you all come at once here. Is my name red or green on the board for you guys? You guys are all green. It is red, okay. Nice writing, Rachel. I find it very difficult to write in here for some reason. Yep, sine inverse of square root 3 over 2 is in fact pi over 3. We're looking for tangent inverse of 0, tangent inverse of negative 1. Ooh, careful. Tangent inverse of negative 1 is where your sine and cosine values are going to be the same. Only one's positive and one's negative. So right here is where tangent inverse of negative 1 is occurring. Notice how you have a negative value over a positive value that are the exact same. That's going to give you a ratio of 1, right? So that should be our 7 pi over 4. Oh, thank you, Isaias. I'm going to just put a smiley face next to that instead. Tangent of 0. So you're looking for 0 over a number. The only place that that happens between quadrants 1 and 4 is at 0 degrees, right? Right here. So 0 over 1 is equal to 0. So that's happening at 0. So it seemed kind of like a trick question there, but that does occur at 0. And then the last one is negative 1 over square root 2. We don't recognize that as one of our ratios that's there, so we do have to rationalize that by multiplying by the square root of 2. When we do that and rationalize that fraction, it becomes negative square root 2 over 2, and that is going to be one in our ordered pair somewhere. In fact, that's going to be where it starred by 7 pi over 4 there. So we're going to go ahead and put 7 pi over 4 for that value as well. Okay, so some of these we had to do a little bit extra work on, like that, the second to last one there, and others we had to really be careful with the tangent ratios. All right, other than that, any questions with these inverse features or inverse functions?